Every year, across wide plains, rural highways, and enclosed corridors of steel and rubber, a unique logistical challenge unfolds. Transporting animals that don't want to be transported, buffalo that buck against steel, wild boars that slam into corners, bulls whose instincts turn metal trailers into battlegrounds. This isn't about brute strength or heavy enclosures. It's about mechanical intelligence, engineering that predicts behavior, redirects force, and transforms unpredictable aggression into something manageable, measurable, and above all, safe. Modern agricultural engineering doesn't see aggressive livestock as problems. It sees them as patterns. Patterns of movement, vibration, reaction. That's why the most advanced transport systems for dangerous animals borrow logic from systems designed for another type of unpredictable flow: grain. Grain chutes adjust themselves according to internal resistance, altering the angles, pressure points, and flow speed of millions of particles. Now imagine that principle scaled up, not for seeds, but for living, muscular cargo. Trailer bays that adapt their structure based on behavior clusters, triggered not by sight, but by force sensors and vibration detection plates beneath the floor. What was once a static crate becomes a responsive environment, a system that listens, feels, and shifts. When an animal charges, the structure doesn't resist with brute steel. It flexes. It absorbs. Shock-absorbent gates, inspired by the same hatch design, used in underground mining blast corridors, dissipate energy before it becomes dangerous. These barriers are not just walls. They are engineered cushions with layered materials that redirect force without collapsing. The goal isn't to trap aggression. It's to neutralize its momentum, mechanically, silently, invisibly. But force is only one part of the equation. The real challenge is what happens before impact. When stress builds invisibly, highly reactive species like bulls or boars release surges of cortisol with every unexpected sound, sudden jolt, or visual confusion. High stress doesn't just lead to dangerous behavior. It leads to weight loss, bruised meat, reduced yield. That's why precision transport trailers now include ambient control systems that adjust not only temperature, but also monitor collective movement patterns. Clusters of motion that signal rising agitation. These systems recalibrate airflow, dim lighting, and adjust internal partitions, all in real time. It's not climate control, it's emotional regulation by machine. Imagine a tunnel built to withstand a blast. Each section engineered to fold, not fail. Now crossfade to a livestock loading bay, where animals pass through a series of gates, designed with the same logic. Pressure equalization, controlled redirection, no hard corners, no blind ends. In both cases, the mission is the same: manage energy before it becomes destructive. This is not just transport. This is containment as choreography, where each panel, each gate, and each sensor becomes part of a mechanical language that speaks to instinct, deflects aggression, and protects both cargo and handlers. Welcome to a world where engineering thinks ahead of rage, and where aggression is not resisted, but redirected with precision. Aggression in animals doesn't begin with a charge. It begins with a vibration. Beneath every metal trailer used to transport bulls, boars, or buffalo, there is a hidden frequency, the deep hum of a diesel engine transmitting pulses through steel floors. These pulses are inaudible to humans, but resonate in the bones of horned animals. To them, it's not transportation, it's a signal of threat. Hooves tense, shoulders lock, aggression escalates before the first wheel turns. What happens next is a chain reaction, a rage loop. One animal responds, shifting weight suddenly. The vibration echoes through the enclosure. Another reacts. Within seconds, the trailer becomes an amplifier for fear, translating mechanical rhythm into biological response. The trigger isn't violence, it's architecture. That's why the newest generation of livestock crates borrows from aerospace engineering. Inside aircraft, sensitive components are protected from turbulence by shock mitigation platforms. floating systems that decouple vibrations from cargo. The same principle now protects aggressive animals. Suspended floor panels absorb vibration. Acoustic panels line the walls. Instead of one structure reacting to every bump in the road, each animal is now isolated in a pod that feels surprisingly still, even while in motion. But innovation creates its own paradoxes. When these sound-dampened crates were first deployed, incidents of aggression dropped sharply, a 63% reduction in injuries caused by panic-driven movements. Yet a new problem emerged: respiratory stress. The same enclosures that eliminated noise also trapped heat. Poor airflow led to spikes in body temperature, shallow breathing, and in some cases, fatal overheating. Silence had solved one problem but introduced another. The lesson was clear. In systems built for life, nothing can be treated in isolation. Sound, air, light, and motion must be part of one intelligent structure. Some of the most effective solutions come not from laboratories, but from the field. In southern Brazil, one rancher experimented with polymer flooring, typically used in farrowing crates for piglets. These mats, designed to insulate newborn animals from hard surfaces, turned out to be excellent sound diffusers. When installed beneath bull trailers, they cut internal echo, softened vibration, and provided better grip, reducing both panic and slippage. The result wasn't just fewer injuries. It was calmer animals, better meat quality, and a loading process that once took 2 hours, now completed in less than 1. Because when aggression is misunderstood, we build fences. But when aggression is studied, when it's treated as a response to environmental cues, we build systems. Systems that reduce triggers, that decode stress, that transform motion into safety. The truth is, you don't manage aggression with strength. You dismantle the architecture of fear. 1 degree of heat, 1 decibel of sound, 1 vibration at a time. When we imagine animal containment, we often think of fences, walls, cages, structures that hold. But the most dangerous enclosures are not the ones that fail to restrain. They are the ones that ignore instinct. Inside rectangular pens or trailers with hard corners and visual barriers, animals lose the sense of space. For species like cattle, that loss becomes panic. When they can't see an escape, they don't freeze, they surge. Heads swing, horns collide. In a matter of seconds, pressure builds in the corners, bones meet steel, and the entire structure becomes a site of trauma. This is where geometry becomes a form of animal psychology. Traditional containment was built for strength. Modern containment is built for flow, inspired by S-shaped silos used in grain systems, which control mass flow by guiding material through variable width curves. Livestock trailers now adopt similar principles. The path is no longer straight. It bends. It narrows, then opens. Each curve interrupts panic. Each shift in width encourages forward motion without confrontation. It's not a fence. It's a funnel for instinct. When enclosures are designed around rotational movement, resistance during loading drops drastically. The numbers are precise. Up to 48% reduction in pushback and aggressive turns. That doesn't just mean safer animals. It means safer workers, fewer bruises, cleaner loading sequences. And time, the most precious resource in high-volume transport, shrinks. In some operations, loading time per head has dropped by 34%, with no added automation, just better design. This design shift is not theoretical. In 2023, a transport cooperative in Mato Grosso began deploying mobile units with internal corridors shaped like mazes, not to confuse, but to control. Animals walk along paths that feel natural to them, with no hard lines of sight, no direct collision courses, and just enough curve to ease their momentum forward. The results were immediate. Bites between transported boars dropped by more than half. Veterinary interventions for transport-related injuries declined sharply. The process became not only safer, but smoother, quieter, and more precise. Because in the world of aggressive animal logistics, the true enemy isn't the animal, it's friction. Friction between instinct and infrastructure, between motion and geometry. Containment in its most advanced form isn't about confinement. It's about choreography, about turning fear into forward movement through space that thinks. In trailers shaped by behavior, peace is not imposed, it's designed. Shape dictates safety, and when design aligns with instinct, even the most dangerous animals move in silence. There was a time when transporting aggressive animals meant building stronger cages, thicker bars, and louder restraints. A strategy based on resistance. But resistance alone doesn't move the world. Today, what keeps the food chain running isn't force. It's flow. Flow of energy. Flow of movement. Flow of instinct, redirected through structure. Modern livestock transport is no longer a reactive system. It is predictive. Every trailer becomes a kinetic ecosystem, balancing weight, temperature, vibration, light and pressure in real time. What looks like a simple box on wheels is, in reality, a responsive habitat, a space that senses behavior and recalibrates its environment before aggression erupts. From the moment the ramp touches the ground, each animal's trajectory is guided not by fear, but by engineering. This shift mirrors changes happening in global logistics. Consider the crates used by Lufthansa Cargo to transport high-stress primates. These containers are fitted with dynamic pressure regulation systems that adjust in-flight conditions based on biometric feedback, real-time pulse readings, sound level monitoring, airflow shifts. The animal doesn't just move, it is monitored and supported as a living, reactive body in motion. The technology that protects an endangered gorilla in the cargo bay of a plane is now inspiring the way farmers transport bulls across mountain highways. Behind each crate, there's a principle at work. Biomechanics tuned to behavior curves. Movement isn't resisted, it's anticipated. Containment isn't static, it's dynamic. These machines are not just tools. They are interpretations of instinct, built in metal, rubber, and software. And each successful journey, each uninjured animal, is the result of human intelligence listening more carefully to what animals have always told us through movement. Aggressive animal transport isn't a battle, it's a system, a mechanical dialogue between species, structure, and signal. In this system, violence is not silenced. It is translated, transformed, absorbed, and redirected until what once seemed wild becomes manageable, and what once seemed dangerous becomes predictable. This is the quiet revolution behind what we eat. It doesn't shout, it hums with precision. It thinks before we do, and it flows. One pulse, one step, one calibrated enclosure at a time. The journey of aggressive animals through rural highways, mountain passes, and export terminals is never just about movement. It's about translation, converting instinct into motion, fear into order, resistance into flow. Yet this journey remains largely unseen. Hidden behind insulated trailer walls and coated floors, beneath the routine of rural logistics, there's a quiet intelligence working tirelessly, and it doesn't rely on force. It relies on design. What makes this system extraordinary is not only the machinery itself, but the principle behind it. At every point, from the first step up the ramp to the final gate release, the transport system is interpreting signals, shifts in weight, tremors of stress, sudden drops in temperature, subtle noise, escalations. It's an ecosystem in constant dialogue with its cargo, not through words, but through mechanics. Sensors don't just detect motion, they anticipate pressure surges. Materials don't just resist impact, they absorb, redirect, and adapt. Every corner is calculated, every texture is chosen, every curve is built to think. We're not talking about cages or containment in the traditional sense. We're talking about behavioral architecture, systems that move animals the way water flows through a channel, not by forcing direction, but by shaping the path. It's a choreography of engineered calm, not passive, not accidental, but deliberate, because every outburst averted is not just a gain in efficiency, it's a gain in safety, in animal welfare, in economic viability. The innovation here lies in the humility of the approach. Instead of overpowering the animal, the system learns from it. This is not a showcase of brute technology. It's a mechanical reflection of biology, sculpted by engineers who understand that time, temperature, vibration, and visibility are not just environmental factors. They are behavioral triggers. And when you control the environment, you guide the instinct. From the outside, a livestock trailer is nothing special. Metal panels, rubber tires, hydraulic gates. But inside, it's a living infrastructure, calibrated to avoid trauma, reduce cortisol, and deliver an animal in the same state, physically and mentally, as it was when it left the farm. That's not logistics. That's biomechanical stewardship. Because in the end, the most sophisticated part of this operation is not the horsepower of the truck or the strength of the barriers. It's the silence of what could have gone wrong, but didn't. The absence of chaos. The smooth arrival of animals that never had to fight their way through the system. That silence, engineered, not accidental, is what feeds the world. And that is the true power behind modern agriculture. Systems designed not to be seen, but to work. Relentlessly, intelligently, precisely, so that what we eat and how it moves reflects not just strength, but understanding.